Here in Lecture 15, we're going to take a more detailed look at lambda expressions. Lambda expressions are one of the most important innovations added to the C++11 standard that makes it much simpler to write in place functions for algorithms such as transform and for each to use. We've looked at many different ways of providing functions for algorithms like transform and for each. We've seen that you can use a handwritten C++ function by giving the name of that function. Remember, the name of the function is a pointer to the function, and the algorithm can apply the function call operator to that pointer in order to invoke the function. We also saw that you can extend this idea a little bit through the creation of function templates, and then you can instantiate the function template with types or with integer values. You can use standard library functions like square root and sine and so forth. Often these standard library functions are overloaded so that they will work with a variety of different parameter types. And so to use a standard library function, you frequently have to go through the mess of writing a cast to specify which of the overloaded versions you would like. You can use handwritten function objects. Here you define a class that contains an overloading of the function call operator. The class may or may not contain some additional state information, such as a value to add or to multiply by. And you can then construct one of these function objects by calling a constructor on the class and use that as an argument to transform or for each or various other algorithms. There are a variety of standard function objects that we took a brief look at that allow you to do things like arithmetic, equality and inequality comparisons, and relational comparisons. We took an extremely brief look at this nasty thing called bind that was designed as a mechanism for combining together the standard function objects and other kinds of functions or function objects to do fairly sophisticated comparisons or calculations. But bind is really obnoxious. It's a real pain to learn how to use bind, and even once you do understand how to use bind, it's nevertheless difficult to read a bind expression even after you've written one. So lambda expressions were invented as a way of bringing simplicity and in-place definition without any loss of power relative to these other techniques that we have. So a lambda, or lambda expression, is an anonymous function that you just define in line in your code at the point where you would like to call this function. Now, a lambda is part of the language, so you don't need to have any header. You can just define a lambda and use it. To introduce a lambda, you type a pair of square brackets. This is literally called the lambda introducer. It tells the compiler that you're in the process of defining a lambda expression, that is, defining an in-place function definition, and you enclose one or more statements in curly braces as you would do with an ordinary function. So here we have an example of a lambda expression that only contains one statement, namely it displays to see out the string lambda in a new line. Now, this is a function definition, a lambda definition, I should say, and so to invoke this lambda, you use the function call operator on the end of it. All right, so here is where we defined our lambda, and then if we would like to call the lambda, we add parentheses at the end of the lambda, and that will cause lambda and a new line to appear on the screen. Now, I just noticed a typo here. This double quote is in the wrong place, so that should obviously be after the \n. Most of the time you do want to have a name that you can use for the lambda, and this is easy to do by using our good buddy auto. You say auto and give the name that you would like to use for the lambda, and that name is then initialized to the lambda definition. And then later when you want to call the lambda, you simply give that lambda name again with the function call operator. Now, it's easy to send arguments into a lambda you can use parentheses between the lambda introducer, the square brackets, and the body of the lambda, the curly braces, to specify the names and types of any parameters that you would like this lambda to be able to receive. Here we're specifying that lam2, the name that I've given this lambda expression, is expecting to be provided with 2 int arguments, and all lam2 will do is to display the values of those arguments separated with a space and ending with a new line. Okay, so I first define the lambda, name it lam2, and then here at the bottom of slide 4 is a call of lam2 with 4 and 8 as the 2 int arguments. It's also perfectly possible for a lambda to return a value. You simply use a return statement inside of the body of the lambda. And in a very simple case such as this, we've defined a lambda that we've named lam3. Lam3 is taking 2 int arguments, and the compiler knows that if you add an int to another int, what you get is an int, and consequently the compiler will infer that this lambda returns an int as its value. Alright, so here I am calling lam3 with 4 and 7. That's going to return 4 plus 7 is 11. I haven't chosen to do anything with that 11. That is, I haven't assigned it to an object, I haven't displayed it, so the 11 just sort of disappears into thin air. But nevertheless, that lambda does return the int value 11. Now, let's suppose that you want to specify the return type rather than having the compiler deduce the return type for itself. It turns out, for a lambda definition, we have a little bit of a syntactical quandary, because the lambda introducer has to be the first part of the lambda definition. That is, the square brackets have to be the first thing the compiler sees when it's compiling the code for the lambda definition. We can't put the return type in front of the lambda introducer, or the compiler will get confused when it reaches that return type. You know, why is there a data type sitting here at this point? So what we use is this frankly kind of bizarre notation of the arrow symbol, that is the dash and the greater than symbol, followed by the return type. lam4 here, just like lam3, takes 2 int arguments that we're calling I and j, and it computes I plus j, but the value is going to be returned as a double instead of as an int. Alright, so when I call lam4 with the ints 4 and 7 as arguments, the return value that comes back from that is the double 11.0. Okay, so here on slide 6 and slide 7, we're going to take a look at some simple lambdas and their results when they're called. On slide 8, we will have the output produced by this program on slide 6 and 7. So first of all, on slide 6, we have the first example that we looked at, an unnamed lambda being defined and then immediately called using the function call operator, the parentheses at the end of the lambda definition. And what we see on the screen from that is the black output here, just the word lambda. In the blue code on slide 6, we're giving a name to this lambda definition. We're going to call it lam1, and then we're going to call lam1 with the function call operator, and this time we get lambda again in the output. That's the blue copy of lambda. lam2 is a lambda that takes 2 int arguments and uses those int values for some purpose. In this case, all this lambda will do is to display those values separated with a space and concluded with a new line. So when I call this lambda, which I've named lam2, with these 2 arguments 4 and 8, sure enough what I see on my screen are the values 4 and 8.